It's called as okay. And other definition also I said it. That's not the right definition. What is the underfitting, guys? The model is when the model is not able to learn from the training data, not maximum data, training data. That is called as underfitting. Okay, why this may occur? When the data is less, when there is a very less data which is not having linear data, there is a no linear data, it is n non-linear data will be there. Okay, and there will be, because of the bias, there is a maximum high bias. Okay, now high bias means so these all are interconnected questions. Okay, high bias means when the distance between actual value and the predicted value is very far. Okay, that is, now what is the solution for this? So what is the formula for polynomial algorithm? फिर से सोचो. फिर से बोलो. It's okay, I got it. So it is the x will be same. The x will be same. So you will be increasing the power of x. Okay. Obviously, when the power of x is increased, the slope will also change. Remember this, guys. Slope will also change. Okay. This is called as underfitting. And there is the best way to get it is to increase the degree. Automatically you will be getting into the much better position where your line will be curved like this. Okay, that's the best way. Now there is another one is called, okay, let me show you that. How this data will be there. See, it's a very small. These are some of the situations which are very rare scenario you will be coming across. I will tell you how to identify this. Now, thing is that how to know that this is a problem is arising. Okay? So, how to find out the score? Now, you are saying that if you have a data set and you are saying that if data is not able to learn from if the model is not able to learn from the data, that lead to a problem of underfitting. How to know that? तो स्कोर लेस है तो पॉलिनोमियल डाल देंगे क्या? There will be n number of reasons. Now outliers रहे तो भी स्कोर एकदम लेस आएगा. तो हाँ, तो स्कोर रेस आया तो क्या पॉलिनोमियल डालोगे या आउटलायर में डालोगे? ग्राफ, अगर ग्राफ नहीं बना के करना है तो हाउ टू फाइंड आउट द स्कोर? स्कोर इसमें क्या देते हो? So what you will get is that score. So what is the testing accuracy you are going to get? Training accuracy, X train, Y train द्वारा उसमें. Got it? Whenever you are not able to get it, just imagine that you are having a data, that model is performing very bad. There may be n number of reasons, guys. I told you, outliers will be a problem. You can remove the outliers. Now, then afterwards, you are doing a wrong encoding where there is a one hot encoding come up. You are putting a label encoding or the ordinal encoding. Then also it will come a problem. Then the other situation is scaling mechanism. What is the scaling mechanism? What is the scaling mechanism? Standard scalar and min-max scalar. Standard scalar comes under the category of standardization. Min-max scalar comes under the category of normalization. This can be also a problem. After doing all these things, still you got it. Then check the graph. Then either it will be an overfitting or underfitting. Now overfitting, underfitting means the data, the model will be not able to learn from the data. How to know that? Simply put it in the score. To simply put it in the score, training X train and Y train, the data will be, the accuracy will be very, very less. Now, when it is accuracy is 100%, and your prediction is almost like 20-30%, there's a lot of difference is there. In the training accuracy and testing accuracy, there's a lot of difference is there. This comes under the overfitting. Okay. So let me show you first graphically this one. I'll write it as polynomial. Again, see guys, this is not an this is not the, actually you will not find it so regularly in your whole of this thing. What is this polynomial this time? ठीक है, इसी में डाल देते हैं. So here I'm going to get it like poly regression class. So import pandas as P and import numpy as NP. Okay. Just let's take a normal, linear data, and then I will put on the best fit line in that. Okay, then you will understand how a best fit line look like. Then afterwards, we will take a non-linear data, and then I will put on the best fit line. That is a linear line. You will understand the difference. And then we are going to apply the degree so that the line is curved. Okay. First, let me take it linear data, guys. Linear data. Just give me 1 second. I think this is an simple linear regression. Hope so. Simple linear regression here. So I will take this data, guys. Okay, this data is there with you. Already it's there with you. So just try to open it and try to do it, guys. So simply Now, first arrange the data in the normal graph. So the data should be in the linear fashion. Now I will get it as df1 is equals to pd.read underscore csv. So, dot selection. How to apply the complete linear regression, guys, on this. Again, see, lot of people were asking me this question. So when I'm applying the encoding, so there are a lot of columns are coming up. How to deal with that? That's not a big problem. Whatever may be the columns coming, you can ignore it and apply it. Encoding is very, very important. Remember, when you go into the NLP, so your column will be in thousands and your actual data will be in hundreds. Okay, actual rows will be somewhere around 800, 900. The columns will be in thousands, 3,000, 4,000, something like that. So it's not a big problem. So you can apply it. This is our data, guys. Okay. Now, what is this X in this? X is what? GPA. So DF1 of CGPA. Which will be getting it as an X. So this should be in the double square by data frame or 2 dimension. DF1 of next one is package. Okay. So I got it. Now next step is train test split, or just I will apply it like that because you know it. You apply the train test split. I will just put on the graph over here to show you. So columns में 200. Okay. From mat.lib import I got as PL. Got it? PLT dot, there is something called as scatter plot. Scatter. In this, I'm going to put on the DF1. Sorry, I will put it X and Y. See this, guys. Is this a linear data? Yes. So I want to put on a straight line on this. So if I want to put on the straight line, see this. To understand the relationship between the dependent and independent. How to get the relationship between dependent and independent? How to get the relationship between dependent and independent? Correlation. पता नहीं कहाँ जा रहे हो यार? I asked you how to find out the relationship. What do you call it as relationship between independent and dependent? Regression. So this is a linear data. How to apply the regression? This is called as linear regression. So how to apply the linear regression, guys? First, let me split it. Scalar dot linear underscore model import linear regression. Okay, linear regression. So I'm creating a model. LR model is equals to linear regression. Okay. Now I'm not splitting the data. Remember that I'm not splitting. I'm taking the entire data set. Now you split it and find it out the accuracy and then find the graph. Okay. LReg is my model. LReg model. LR model. This I have to feed the data. How to feed the data? How to feed the data? What data I have to feed it? X. But I don't have X train and Y train. X and Y. You can give it X and Y. No problem. When there is small data, see, simple guys. हम लोग splitting क्यों कर रहे हैं? Why you are splitting it? क्यों कर रहे हैं? क्यों करना है score find? Why you want to find the score? सुनाई नहीं दे रहा, सामने आ जाओ. हाँ, to find out. Okay, complete data guys. Okay, उनमें से क्या करें? 80% we are removing it. 80% we are removing, and I'm giving this data to the training. Right? Clear? Okay. Now what you are doing to the 20%? Testing it. अब पूरा दिए तो हाँ जाएगा मतलब क्या? लर्न करेगा तो प्रिडिक्शन क्यों नहीं आएगा? I said that prediction. टेस्टिंग के लिए नहीं, प्रिडिक्शन बोल रहा हूं. मालूम नहीं पड़ेगा आपने, but you can give it when you have a small data. When you have small data and there is a lot of small data, like 100 records are there. Now usme se if you want to split it, 20 records are gone, so only 80 he has to learn. So when the small data is there, give it full data. Don't split it. Give it full data and directly do that prediction. See that whether you are getting the accuracy or not. Just you can check it out. Okay. When the small data is there, when the large data is there, then you split it into two parts and give it a training data and testing data. Now here I am giving it the x comma y. It will learn from complete data. It will learn from the complete data. Next, what I have to do? Okay. X comma y. यही देना है और कुछ और है तो नहीं अपने पास. 77%. Okay. It found the variation. There is a difference is there. It was not. It prepared a model. It prepared a formula. वो formula fit नहीं हो रहा उसको. पूरा 100% तो fit नहीं हो रहा. Sorry. It can be n number of reasons. Okay. Now, now I got 77%. Now I want to draw a straight line. Okay. Now straight line. How you will draw a straight line? When you will draw a straight line? No, just go through the formula which I told you earlier. I told you how to get the y is equals to mx plus c. How to find out the m, how to find out the c, and how to find out the residual. And if do you remember it? So first what you'll do it is how to know that this model is running perfectly now. previous data. So what is there is here, this is independent data, right? This is independent data. So when I train this one, so it will get some understanding. It will get some understanding of the data. It will learn from that data. Now after learning, how this accuracy is coming into the picture? How this accuracy is coming into the picture, guys? See, what it is doing is, in this formula, it is putting the X data. And what it will give? It will give the output that will be coming in the predicted format. Like this. You see, our model dot predict. Give it X over here. So what it will predict? Y value. So it will predict all the Y value here. So this is X predict. इसका है ना? Y predict. Now this is the predicted value. Okay. What is the actual value? Compare them both. When you compare them, then you will get the actual accuracy score. That is being done over here. Now I am applying manually. In this case, it is doing the same thing. Okay, it is taking the X and it is putting in the formula whatever it learned in the model and getting us some score, some output. That output is compared with the actual output, then you will get the score. Okay. Now when I did it over here, in this I want to plot. See this, I will do it once again. Plot dot scatter X comma Y. I got it. I got this one, guys. Now in this plot ELT dot plot. Okay. I'll get X comma Y will be I predict. Now let's see this. I got a straight line. Can you see that? This is the best fit line. Now, okay, let me change the color of this line. Now see this. Now this is the best fit line. Got it, guys? Okay. Now we are almost done with the regression. There is only lasso and ridge regression. We have to learn it. Now this is about the best fit line, right? Now I want to show you the polynomial regression, right? So the data should be different. This data we can't use it. Again, you will get a very rare scenario. I was able to find this data. Okay, these are very small data, guys. Only some small 10 records, 11 records are there. Let me show you how it will work for us. Okay. Now, what is the location of this? Let me get it to the main. Yeah. So I want to get the polynomial. You finished with this one. Again, without splitting or with splitting? Huh? Without splitting बोलते हो, copying बोलते हैं उसे. So with splitting करो. I want you to do it. Again, with splitting with the graph. X train, Y train, and X train and Y predict. Done, guys. Now let me do the polynomial. Name is top selection. Now DF salary. Now let me keep it DF salary, guys. This is the one. See this, guys. Okay. This is the, now ignore the positions. Again, we have to do the inputting and all those things. I will ignore the positions. So DF salary is equal to DF salary dot top position access is equals to 1. Now this is my data set. Okay? Now just take it. The level is that you can take it as experience. Okay, level 1, level 2 is an experience kind of stuff. Now next one is salary. Okay, let's see the data. If I scatter plot, PLT scatter. Now this one is, first one is, let me put it in the X for DF salary of level. Okay. Now X is equals to level and Y is equals to, keep it as DF salary of salary. Okay. Got the Y and X. I'm forming a scatter plot. Now let's see that how the my graph is. PLT scatter. Okay. X comma Y. Okay. Antena? See the data, guys. Is this linear? No, it is not linear. It is going up. Okay. So I want to draw a line. So in order to draw a line, first I have to create a linear regression model from sklearn.linear model import regression. Now I'll say that LREG is equals to regression. Okay. Now inside this LREG will be learning from one X comma Y. Okay. Now LREG dot score, if you want to see it, you can see it, the score also 66%. Okay. Now what I'll do it is LREG Now I want to create a straight line, right? I have to get the predict, x predict, right? So predict of x, store it in y predict. And why you are doing this? To compare the predicted value and actual value. What is the actual value? Y. Predicted is this. Here, now I am going to put the graph once again. PLT dot scatter x comma y. Next, I have to draw a line. So PLT dot plot by red. Color is equals to red. क्या हुआ? Is it okay? Okay. It's learning from how many? 1 and 2. This one is also not, it's not doing, it is passing very close. Now rest of all are very, very far. You see it. You can say this one it turned a bit, this one it turned a bit, this one and this one no. So this is a problem. If you are predicting something else, it will not get it. So to avoid this, what you are going to do it? So you have to curve, you have to make the line curve over here. So again, how to apply the polynomial regression? Atish మాట్లాడితే చేసి polynomial features ఎవరికి ఇస్తావు? Where you want to put down that polynomial features? Always independent data. What is the independent data? X. X is the independent data. So first, yeah, that's right. PLT, not PLT, from scalar dot import features, polynomial features. Inside this, what is the degree? What is default degree? 2. 2 is the default degree. So how many columns you will get it? 3 columns. What are 3? Degree 0, degree 1 and degree 2. X to the power of 0, x to the power of 1, and x to the power of 2. Now this I will give it as poly. Okay. Now this is the poly. So I want to first do the data to learn and then transform it. First, I will give the data poly dot fit which data? X. Okay. You will give it as X poly. So guys, here I am having only X. What if there is a large volume of data is there? If there is here it is small volume of data. So I am giving complete data as an X. Now when the large volume of data is there, you will split it. Then how this will work? Which one you will learn from? Okay. Then what? Wrong. Yeah. Huh? So see, the basic point is independent data. That's it. If you are splitting it, suppose you are splitting it, guys. If you are splitting it over here, do you have anything? Okay, if we are splitting the data like this, so what will happen is having the right. So if I am having some data like this, small data, observe this, small data is there. Then what I'm doing is I'm splitting this data into independent data and dependent data. That's it. Nothing else I'm doing it. Like this. Small data is there. I'm having, this is my X. This is my X and this is my Y. Okay. So whenever you want to apply the polynomial regression, polynomial features, always apply to the X. This should be capital X. Sorry for that. Apply it on the X when the small amount of data is there. You will apply it. That is poly dot fit of X. That is, what is the fit will do? Learning. Now after this, poly dot transform X. Now what you are going to get it? X poly. Something like this. X poly. Now it is by default, it is degree is 2. If here only one column is there, 1, 2, 3, 4 and 5, something like this is there. So how many columns after this we'll get it? 3 columns, right? One is x to the power of degree 0. Next one is x to the power of degree 1. Next one is x to the power of degree 2. Now anything to the power of 0 is 1. So here we are going to get it 1, 1, 1, 1 and 1. Here same 1, 2, 3, 4, 5. In this squaring 1, 4, 9, 16 and 25. This is what the transformation happens. Okay. Now this data you are going to give to the model. After transform whatever, if my model is LREG dot fit, I'll give it as X poly, comma Y. Y will be as it is. We are not going to touch the Y. Only the X poly we are going to give it. If you want to implement the polynomial feature, then automatically the accuracy will be increased. Definitely it will increase. Okay. But the question is not this. This is a simple model I'm showing you to understand, because I'm not getting a polynomial. I tried it a lot yesterday. A polynomial data, I didn't get it. So if you are having a very large data is there, very, very large data with the multiple columns, maybe around like 10 columns are there. And this is like maybe 50,000 records are there. Now this is non-linear. The data is non-linear. So when you are going to get the X, how many columns? 9 will be X. 9 will be X. And 1 will be Y. So my X will be having 9 columns. Y will be having 1 column. Now this is a very huge data. You can't give it all the data for the training. So what you are going to do it? First, X train, Y train, sorry, X test. X test, then Y train, Y test. Okay guys, clear? Now in this, now as I told you, the base fundamental property is the polynomial will be applied on independent data only. Now scaling mechanism, scaling also independent data only. Okay, remember that scaling and polynomial are applied. Now I will tell you what are the things will be when we see it in the future. So remember this thing. Scaling and polynomial both will be applied on the independent. What is independent over here? X test, X train and X test. So now see this. Which one is having the more data? X train. So give this X train to your poly. Poly dot fit X train. Okay, it learned from this. Then transformation, poly dot fit transform. Sorry, transform which one? X train and X test. Both you have to do it. Both you have to do it. Learning should be done by X train and transformation should be done on both. Remember this. Okay, don't forget this point. Because our data is very small, so I'm directly applying. This is a very important point. Now, in this case, I'm giving it fit. It's done. No. It's done. Fit. Fitting, why are you giving this? Okay. Now it will transform. X poly is equals to a poly dot transform of X. Now you see your X, and now you see your X poly. Right? The difference. This is the original data, and this is after polynomial. Right? This one I will give to my model. Can I give to this model? No, because it is already learned from the X. So you should always create a new model. Okay, remember that. You should always create a new model. I'll give it as LR model. It should be fresh model. Linear. Okay. LR model, but fit. It will fit from X poly, comma Y. Now then, score. See this, what is the accuracy over here? We did it, yeah, 66%. Now, after applying the polynomial features, I got it 91%. Now, this seems to say that your model is learning a lot, right? But how it is learning? This is your graph. It is learning. So it becoming like this, a bit curved over here. In this, see if I can paste it. So now look at this. This is my original one. Okay. This is my original one. So when I apply the polynomial, what it will happen? It should become like this. It should be going. It should go on like that. Then only it makes sense. Now see this. This is the way it will be going. Not exactly. थोड़ा बहुत इधर उधर adjust करूँ. Okay ना? Now this is degree is what? Degree is 2. Now if I increase the degree 3, then what will happen? So it will come very close to the data points, very, very close. So it may go like this. Not 100%, but it is much nearer. Like this. Now, if you make it this one, 10, then it will go point to point. Then this is a big problem. This is a big problem. You should never do that. Keep it around 3, 4 or something like that. Don't go with 20 or something. It will be a problem for you. So, will I get this one? I have to check it out, right? Will I get this one? So now let's go back to us. TLT scatter. You can say that X comma Y. This is what it is, right? Now I will do it. We didn't do the predict, right? We didn't do the predict. I'm going to do the predict over here. Hybrid is equals to LR model dot predict X poly or bus X poly. Now after doing this, I want to plot a graph. PLT scatter X poly comma error आ रहा है. ये क्या हो रहा है? It's going on this way. It's taking like this. Let me keep it over here X. Okay. ये X poly बोलते ज्यादा हो गया, 4 है ना, वो 4 ले रहा है, तो इसलिए. So is this perfect one? Yes, this is a perfect one actually. Now let's increase the degree. कहां से करनी है? यहां से करनी है. चलो करते हैं. From scalar dot no need learn pre-processing learn pre-processing. Okay. Now import. What is that? Polynomial features. Okay. Now I am going to make it as poly 3. Means the degree 3 is equals to polynomial. Okay. In this, give the degree is equals to 3. Okay. And इसी में करते हैं. Or let's do it in a separate and then we combine. Then poly 3 dot fit which one? X. And here X poly 3 I will give it. ठीक है? No need fit के लिए जरूरत नहीं. And then I'll do the transform also, guys. Poly 3 dot transform X. I'll give it as X poly 3. Okay, we got it now. Now let's create a model. LR model for 3 is equals to linear regression. Now LR model 3 dot fit which one? X poly 3 comma which one? Y. Okay. After this, like I will use the predict. LR model 3 dot predict and I will give it as X poly, sorry, poly 3. So here I will get it as Y predict 3. Okay. I will get this one. Here I will give it as 3. See this? Got it? There is a difference is there. Okay. There is a difference is there. Now let me put all these things in a one single line, one single column. This one. Okay. Next, this one. ट्रांसफॉर्म एक ही में करते हैं. then model, and learning, and then predict, and then scatter plot. Okay, now I will make it as 4. This will become 4, 4, 4, and this also become 4. I'm making all as 4 because we are given the degree as 4. Okay, and here it will be 4. Let's try it out. Now you see. Okay, now look at this point. These two are missed out, and here this one is missed out. Here you see, almost passing through that. Now, if you take it 5, then it will be even worse. Still 5 is okay because it's not 100%. Is not doing. If it is, sometimes it will be point to point. Perfect. This is the actual one. See this. This is the best one. This is okay. You take it. This one is also best because still it is not going with a 100%. Okay, they go. And this one is like worse, point to point. If you increase more, it will be more and more close to you. So that will be a problem for your model. So this is a way you will be implementing your polynomial regression, guys. Okay. So this is what is about the polynomial regression. Now, what is the overfitting? Now, this is, if it is, we are doing it more and more, it will become an overfit. So what is the problem if it is an overfit? Now, let me increase it. I don't know like whether it will work or not. I'll give it as maybe 10. It will accept or not, I'm not sure. I never tried it. But this itself is an almost like an overfit. And here also I'll give it as 10. Is an invalid. Is equals to is missing. Is equals to missing. So this. It's perfect like point to point it is going on. So this is the case of overfitting, guys. So there will be a slight difference will be there. The good fit, the underfitting is completely this one. Okay, underfitting is completely this part. Okay. Now, if you want to go with more and more, like if you give more and more degree, then what will happen? It will become an overfit. So the best one in this is, you can take it as this one, not even this. This one will be the best one. We got it the best accuracy by this only. We got it the best. Now, what is the actual problem with the overfitting is, there'll be two ways you can see the overfitting. One is, the two ways we can get it. First one is, when there is a large volume is there, and all the large volume of data is having a lot of outliers are there, and your model goes point to point like this. It is going from point to point. Just imagine in this is an outlier, this is an outlier, some outliers are there, 50% outliers are there. Obviously, it will learn from the outliers. It will become very comfortable and it will learn from the outliers. Now, if you are asking to predict something, it will predict wrongly because there is an outliers are there. That is the biggest problem. Second case is, when the data is very, very small, the data is small enough. When the data is small, again your model will be facing the same problem. If you take it this one, this is my graph. There's a small amount of data is there. This is one. This is my. Okay. This is one point, and there is one more point is. There's 2 points are there. Okay. Now, when you, or okay, just remove this point. This is the data. You have data. Now, can you please tell me like a line passing through this? Any line it can pass. Any line, infinite numbers. Suppose if there is a data over here, data point. So what will happen? Which line will pass it on? This will be the line which will be passing on from this. Very comfortably, it will be going through this. Clear? Now, it will learn only from these 2 points. It will learn only from these 2 points. And it is exactly learning. It is not even taking here and there. You are not having any more data points here or here or here. Because if the data points are there, what will happen is it will get an equation of y is equals to mx plus c. But here it is y and x are same. So the equation will be, what it will learn? It will not learn anything from that. So what will be problem is, if I am asking after learning this one, if I ask this one to predict a point over here, my prediction point is this, sorry. Use the other color. This is my prediction point. Just take it. So will that be able to predict it? No way. It will not be able to predict it, this one. Why? Because it is very comfortably learned this one. And these are the points I want to be predicted. So then what we will do it is, now see this guys, simple. Try to understand this intuition. Now, when we are here, this is the x. And y is also on this only. And here also x is over here and y, sorry, you can say it as y, actual y is over here and y hat is also on this. Y hat is what? Predicted value. Y is actual value. Here y is over here and y hat is over here. The same point. Same point, exact same point. Suppose this point is, take it as 3. And this point is at maybe 6. Now your y minus y hat is what? Error, which is called as residual, right? Now what is, now take this point. What is y? 3. Y hat 3. What is the error? 0. Now let's take the next point, this one. What is that y? 6 minus 6 is equals to 0. When I add it, I took it as error 1 and error 2. What I'm going to get it? 0. So this is what you are doing. Adding the errors, right? Adding the errors. Now error, how you calculate it? Y minus y add. Y minus y add. So here, if you check it out, now my E is equals to E1 plus E2. Suppose if there is one more point is there, that will be E3. This can be said as summation of E, right? Now how you are calculating this one? Summation of, clear? This is what the summation of the error. Clear, guys? Now the error is 0 over here. Error is 0. This is because it is going through the perfect points, but it can't do a prediction over here for me. This line and maybe, okay, I will ask some other line over here. Something like this. This line I want to predict. This point I want to. So this will not be possible. So what I will do it is, I will slant them. I will slant them. So what I will do it is over here. Just I will take this. Try to understand this one, guys. I'll give you a copy of this. Okay, we got it. So this is the my actual line, right, which is going through the 2 points, and my error is equals to 0. If I take it, my error is equals to 0 over here, right? Summation of error is equals to 0. We know it. Now this will be a problem for us. This will be a perfect problem because it's an overfitting. So what I will do it is, I will slightly move this one a bit, slightly turn the terms. So what will happen is my new line will be coming up like this. It may go through this line. I will slightly, with an angle, I will divert it. It will go through this line. This one. Okay. Or make it a bit over here. If you want to make it, you can make, this is okay. But still, you can try it out, means you can try it out this. Like this. Okay. My line will be going on like this. What is the advantage? Immediately you can ask why we are doing this. See, by doing this, what will happen is your okay, let me do it. Okay, this is the way I'm doing it. See, what is my, now forget about all these points. Forget about all these points. Just look at this. This is my predicted and this is my actual. What is this? You'll at the same point, you'll get 0 over here. Both are same point, right? Just think it, both are same point. E is equals to 0. In this case, my predicted point will be over here. My actual point is over here. What is the error? This point is the error. So in this case, error will be, now y may be at 6 or something like that. Maybe I will get it 2 is the error. Now when I do the summation, what I'll do it? Error will be 2. Okay. Why this doing is, now with this, my line equation will become y is equals to mx plus c. So it will understand the relationship between my predicted and my actual. What is the advantage of that is, with this equation, it can also predict this one. It can also predict this one. It can also predict this one. That is the advantage of it. So you are going to slightly turn that one. You'll slightly turn that one. So the actual line is this, which is going point to point. That is, again, you may ask, that will be very good. But the problem is, it is good with the existing data. It's learning 100%. But the prediction, no. It is not doing the prediction because it is in the comfort zone. It's having the equation y is equals to x, something like this. This equation will be there. This is not right. So what we did it, we gave an error. Clear? But how to give the error? So when this one is there, this line, take this line. This line, what is the error we got it? E1 plus E2 is equals to 0. Now E1 plus E2 can be written as summation of E. But how to calculate the E? Right? Now to this is equal to 0, right? So to this, what I'm going to do it is, again, it depends, square or, square by mean, everything. Usually we will take it as mean square error. Mean square error formula will be summation, see this, summation y minus yi minus y hat whole square. I value will be I to n. Okay. Then we have to find the mean. So this can be also be written as 1 by n summation of I is equals to 1 to n. Okay. Where yi minus y hat whole square. Clear, guys? Okay. So this is again referred to that. If anyone having problem, we can do it. Now this is my actual one. That is summation of y minus y hat. Now I'm not keeping the r square. I'm not keeping the mean square error. Nothing I'm doing. This simple error I'm calculating. To this is equal to 0, right? So when it is 0, it is going from the point to point, right? Point to point. So I'm diverting this line to this one. So what I'll do it, I have to give some error to this. Okay, I have to give some error. That is summation of y minus y hat plus, give it lambda w square. Whichever one you want to give it, w square or summation of the w square, you can give it. Now, what is this w is? This is slope. This is slope. This is the error, guys. We are adding. Now, just like this is 0 is there. If I add it 2, what is that total error? 2, right? In that way, we are adding the error with this formula. That is lambda w square, something like this. This is when slope, when the 1x is there. X is there means what will be the m? M will be 1. If 2x1, x2 is there, how many slopes will be there? M1, M2. So this can be anything. So we can use it. This w is nothing but m, guys. You can keep it as m also, no problem. You can keep it as a m. So the equation will be simple way, guys. Summation of y minus y hat is the original error. To this, we are going to add this is the error. This is the error. Now, this error will be different for lasso. This error will be different for the ridge. This is for the ridge. If you want to do it for the lasso, it will not have the square. It has the modulus m. That's it. Why the module? What this absolute, sorry, absolute, not modulus, absolute. What the absolute will do is it will remove the sign. That's it. Clear, guys? Any questions? Is it clear? Where you have to, why you have to give it means because diverting it from the actual path will giving the error. Now, this is what you are doing. You are giving an error. You are giving an error. So this error is called as giving a penalty kind of. This is called as penalization. The penalization of the module is called as regularization. Whenever you apply the penalty to an to an actual module, the error point, the loss function, when you are applying the penalization to the loss function, that is called as regularization. This regularization can be implemented in two ways. One is the lasso, second one is the ridge, and third one is also there, elastic. Just ignore that, we will never use it. So ridge and lasso, and ridge is called as L2 regularization. Regularizations will be of two types. One is called as ridge and lasso. Ridge is also called as L2 regularization. This is L2 regularization. And this one is called as L1 regularization. There, guys? So I'm going to repeat it again because this will be a very important concept for your regularization. So quickly, I will repeat it tomorrow before implementing the actual program. Okay? Again, these are some of the very, very rare conditions, but very favorite for the interviewers. It is very lucky that sometimes what happens is some of the experienced people, they will keep this one for each and every model, the scaling and the polynomial regression, and also the regularization. Regularization, if you keep it, that's okay. If it is any problem, you will get the accuracy. Otherwise, it will not affect yours. It will be the same. Tomorrow, I will show you how it will be very effective. I have to get a right data set for this. That's a big problem. So tomorrow will be the last day of our regular regression. Okay. After this, we will be jumping into the classification, and rest of all will be classification. Very less we will be doing the regression. Okay. I will show you again after doing the decision tree, we will do a regular regression, and SVM, there is a regression is there, and random forest, there is a regressor is there. This all I will show it one small programs. Okay, guys, is it clear? I will get you some slides tomorrow to explain this one, so that it is easy for you to understand. Okay. And Sunday, what time? थोड़ा लेट मतलब क्या? 10 बजे से मुझे और है क्या? रात में ले लें? संडे नाइट? नहीं यार, घर में मारेंगे. तो नया मूवी रिलीज हुआ ना, मैं तो से बोल रहे थे. I will dump this all in your these things along with the data set. It will be there. You can collect it. Again, I am saying, guys, never get disappointed. Stick to your process. That is very, very important. Don't get disappointed looking at the accuracy. Stick to the process. That is more important. Okay? And itna karne ke liye aapko, no one give you an opportunity to do all these things. This is an experienced people will be doing it to understand those things. All you will be doing is, for senior aake data, he will give you the data and he will say that pre-processing karke do bolke. Bas. Next 1.5 years, this only you will do. Remember that. After that, when you leave this company, the starting company, when you go to the next company, your salary will be double. Okay, that is more important. Then your job will be changed completely. You will be as a next level person where you will be doing it. Got it? And again, I'm saying it. there is a huge demand in Japan, huge demand in Germany, Singapore, Brazil, and of course the US. US अपने वाले already है पड़े हुए. So these are the places where there no people are there. They are starving like anything. So one is Japan, Singapore, Korea, and Brazil, Germany. So they are waiting, like, especially if anyone says that I'm a data scientist, कुछ भी आन दो या नहीं आन दो, वो बात की बात है. Because no one is there to interview them. कोई problem है वहाँ पर. So that's a problem. So there's a very huge demand is there, and they wanted to acquire the people like anything. So if anyone is planning, you can plan it. Okay. So then I will stop it over here, guys. Let's meet it tomorrow. And again, if you have any problem with the regression, whatever we did it till now, so you can come up. I will explain you once again. And after this, no going back. We will jump into classification, means we will be directly going with the classification. Because every day there not much will be there. You know, only the algorithm intuition you have to understand. Then implementation is same. There's not much will be there because KNN the same, logistic regression same. Your Bayesian tree, SVM, NIBase, you will be seeing some kind of actual NLP test. You will be seeing a text classification over there, directly text classification. Then after that, ensemble learning. Ensemble learning is very, very important. That is really fetch you a job. That will be done in next, like, ho jayega within no time. So this is of your machine learning, because this is the biggest headaches, this bias, variance, underfitting, overfitting. This is like very much favorite for the interviewer, especially for the freshers. They will play like anything. If you go with it. Just closing. Okay.